Artificial intelligence-based system for creating the 3D models of the industrial and architectural objects. The system will automate reading the engineered drawings, conversion of 2D drawings to 3D models, combining data from multiple sources to improve 3D models. Digitalization is steadily taking over the process of creation and usage of physical assets. Smart buildings, smart factories, smart cars, smart appliances, and many other digitally managed objects have taken firm root in today's world, and there is more to come. In the construction and industrial worlds, building digital assets and digitizing existing objects is not a fashion, but the efficient approach. It saves resources and provides efficiency and transparency. It ensures timely and preventative repair and quick troubleshooting. Design is at the center of any object, and design became entirely digital some time ago. What started as a simple computer-aided design, known as CAD, has now become an exact digital copy of the physical asset. In the construction industry, these copies are called Building Information Models, or BIM, combining all systems and layers in one single file. Exploring BIM is like being able to travel all over the building itself. Originally three-dimensional, they become 4- and 5-dimensional with adding such parameters like time, cost, etc. Sometimes the physical object and digital replica are connected during the useful life of the asset through multiple sensors. In this case, the digital model is called a digital twin, and it lives along with the asset. Having a digital twin helps to model scenarios of product behavior and thus foresee any issues. Over the last few years, the number of twins for existing objects has grown exponentially, as they have firmly become one of the top technology trends in the world. There are twins of large equipment items, of planes, spaceships, buildings, bridges, and roads. There are even digital twins of cities. Remarkably, twins allow you to speed up time and see the condition of the asset in, say, a year or 10 years into the future. The digital model of the physical asset now lives all along its life cycle. It is created during the design stage as a CAD model, or BIM. During the construction stage, the model is used and updated with as-built drawings. New augmented reality technologies help to see the completed product during the construction phase. During the useful life stage, the digital model is required to plan and install the smart infrastructure tools, or as a digital twin, it exists and operates alongside its physical replica. It is also actively used during renovation or upgrade stages, and finally during the decommissioning stage. The calculations require the exact engineering data, and having a digital model helps to plan the process and required resources and avoid the risks. If the decommissioning is performed in a harsh environment and the object is composed of complex components, the absence of exact data on the physical asset's properties can cost vast resources and time. The problem is that vast majority of global assets were built before the advanced software packages were invented. One of the critical challenges for the growth of the smart buildings or smart facilities industry is that most of the existing assets do not have digital copies. For many buildings or industrial objects, the design is still being kept in paper blueprints or early CAD drawings. To use all the latest technology and software packages, the asset owner must create the exact digital model in the newest format. This means that someone needs to convert old engineering data into a new information model. Most of the conversions are still done manually. In fact, the engineers usually physically redraw from the paper drawings. In cases involving large and complex objects, which can be a complicated and expensive task. Another issue is that the drawings often do not reflect the actual state of the object. Changes during construction and later additions or modifications are often not reflected in the drawings, and the original design is not updated. These challenges complicate things and slow down progress. The absence of accurate digital models in the latest format is thought to be one of the key factors preventing smart object technology from spreading much faster and impacting each stage of the object lifestyle. For example, experts in offshore decommissioning name the lack of engineering data in modern digital formats as being one of the critical industry challenges. The solution lies in the artificial intelligence, or AI sphere. The concept is that if trained properly and provided with necessary analytical algorithms, AI can do the following: recognize writing, symbols and shapes on the drawings, recognizing parts and components of the drawings, translate multiple parameters into a single model, thus producing the engineering 3D model of the object. The demo video, attached in a separate file, shows the recreation process of the steel structure. Above, we have outlined the approach for the drawing recognition and translation of 2D to 3D models. However, as we know, the original model is often different from the actual object. To adjust the original model, we need additional data. This data can be 1. Exact measurements of the object performed with various equipment. 2. Photos or videos of the object. 3. The data from laser scanning the object. Laser scanning, also known as 3D mapping or high-definition surveying, HDS, is the most quick but accurate way of providing the object's shape. It is being performed both indoors and outdoors, with various types of equipment available on the professional market. The result of laser scanning is a 3D drawing of the object performed with high accuracy. However, it does not recognize any physical properties of the object apart from its shape. Laser scanning can provide us with knowledge of the actual shape and, along with analyzing images of the object, can show if there are any missing parts or changes. The comparison process will include all data available, its alignment with the original 3D model, identifying the differences, and deciding on the correction. In the construction industry, this process is called scan to BIM, or point cloud to BIM, and it is still not fully automated. Again, AI algorithms will make it easier and can automate the process by aligning the scanning data with the original model, recognizing shapes and applying the existing data to the shapes of the model, applying photo and video data to the original model, identifying the differences, making adjustment suggestions, decisions depending on authority and level of training of AI. Video Demo 2, attached, shows the comparison of the scanned surface with an original drawing, the finding of discrepancies, and suggesting an adjustment. The system will offer numerous benefits for its users: unprecedented speed of conversion of engineering models into new formats, substantial cost savings for engineering, enabling using multiple digital applications for pre-built assets. It can be used for various industries: civil engineering, architecture, transportation and pipelines, industrial structures, oil and gas, mining, renewable energy, and many more.